integrating, definitely, a rational expression. I have x to the third minus 2x squared minus 4 all over x to the third minus 2x squared, and that's going from 3 to 4. So we go and we factor that denominator. We see that we have an x squared, so we pull it out, and we have an x minus 2 dx, and then what's next? I want to do partial fraction decomposition. Yeah, let me just do this over here on the side. So, since I have a repeated factor in the bottom, I'm going to get 2 copies of x, one of just x and then one of x squared, and then that's plus c over x minus 2. Then we add those fractions, multiplying each one by what their denominator is missing. I know. Okay, so a was missing an x and an x minus 2 from the common denominator over there on the left, and b was missing an x minus 2 from the common denominator over on the left, and c was missing both copies of x. So we keep on keeping on. Distribute in there. All right, distribute in there. All right, c, yeah, he's all right. And then that's all over our common denominator. We gather like terms. So we have an a plus cx, then we have a minus 2a plus bx, and that's a minus 2b is our constant, so we're matching up the coefficients to the left-hand side. So let me rewrite that so that we can have a little bit more room. And in doing so, we're trying to find our a, our b, and our c. RB. Sandwich sounds good right now. Okay, did you hear that girl yawn? Okay, so that we match up our coefficients, and then we have a plus c is equal to a minus 2, because the x squared term has a minus 2 in front of it. And then we have a minus 2a plus b, that's equal to 0, because we don't have a linear term in the left side of our unadded fraction, or our added fraction, and then constantly our constant minus 2b is equal to a minus 4, which gets us that b is equal to 2, and then we take that 2 and we stick it right there, and we have a 2a plus b, or 2a plus 2 is 1, and a turns out to be 1, and then we stick it right there, and it turns out that our c is a minus 3. Now, we go and work with that unadded fraction. Our a is 1, our b is 2, our c is minus 3, and we write that in our expanded rational expression. We unadded it. Oh yeah, you could go faster than that. Faster, faster. Okay, so then I'm there. I put my a, my b, and my c in there. What did we do? We unadded that fraction to get something that was more integrable. So we integrate both sides. That first one's a natural log. That second one's a, yeah. Think of that x as having a minus 2. So then we add 1 and divide by it. There she goes again. Okay, so this had limits, but let me combine those natural logs. Naturally, I put that 3 up in the exponent. It was in front of the natural log, so now that's to the third, and then since it's the difference of logs, that's the log of the quotient. And I'm rewriting that guy right there. Boom. That 2 should be a 3. Catch it. There it is. And then it's upper minus lower. What's upper? Bam. I put the 4 in where it goes. And then that's minus the natural log of that. And notice what I did right there. I distributed in that minus sign, and that's how it became plus. Let's clean that up. Yeah. Rewriting. I don't know why I'm writing so big. I hope it gets smaller. There we go. That's a half after we simplify. Minus a half minus the natural log of 3 plus that 2/3. Combining the natural logs again, and I get 1/6. And then when I add fractions, I get 1/6. Done.